Hello chemistry students. To review for tomorrow's quiz, I wanted to create this video about how to write formulas for compounds. So the flowchart that you see on the screen should look familiar because we did go over this in class. But the first thing that you have to do is look at the compound. You need to look at the compound and decide, is there a metal? How can you tell if an element is a metal or not? You need to look at the staircase. So right over here, I've pasted a little picture of a periodic table, and in a thick black line, I drew a staircase. Now, anything that's to the left of the staircase are metals, except for hydrogen. Remember, hydrogen is the exception. And anything to the right of the staircase are the nonmetals. So if there's a metal in the compound, follow the arrow to the yes. That means that the compound is ionic. You need to balance the charges so that the net charge or the total charge on the compound is 0. But let's look if your answer to the question about metals is no. If you do not have a metal, that means that the compound that you're working with is covalent. You do not need to balance the charges. All you need to do is to use prefixes to write the formulas. But the next question that you need to ask is it a part of high Broncliffe? What that means is the compound that you're trying to write called hydrogen, iodine, bromine, oxygen, nitrogen, chlorine, or fluorine? Because if it is, that means that you would add a subscript of a 2 after the symbol. But if the compound that you're writing is not one of these elements that are in high Broncliffe, then you're just going to follow the rules here for all of the covalent compounds. Uh-oh, I got to rewrite Broncliffe. There we go. All right, so let's just do a couple of examples. So let's try the compound Magnesium Sulfide. So when we first look at this compound, the first thing we need to do is we need to draw out what the elements abbreviations are. So magnesium is right here, number 12, and it's to the left of the staircase, so that means that magnesium is a metal. So when we follow all along, is there a metal? Yes. Then it's ionic, and we need to balance the charges, so the net charge is 0. What that means for us is that we need to figure out the charge of magnesium and the charge of the anion, which in this case is sulfide. Well, sulfide is the anion, or the ion, of the element sulfur. Sulfur is on the right-hand side of the staircase, which means that it is a nonmetal. Okay, so all of those parts were the easy parts. What we need to do now is review how to figure out what the charge of magnesium and what the charge of sulfur is. So look at the periodic table. What I'm going to do is I'm going to number the columns, the families, as they go up and down. So my first column is 1, 2, 3, 4, 5, and I'm just going to keep on numbering. Now you don't have these numbers on your chem helper, so you just have to be able to count for yourself. The reason why I'm numbering all of them is because we need to know what the last number of each group is, or of each column is, because that tells us the number of valence electrons, and that's going to help us figure out the charge. Okay, now, as we go on, remember that anything to the left of the stairs, these are the metals. And recall that metals are going to lose electrons to form ions. And in fact, they're going to lose all of their valence electrons. So by knowing how many valence electrons they have, we'll know the charge, because the charge is going to be positive since they lost electrons, and then the number that follows the positive sign tells us how many electrons it lost. Now for the other side of the stairs though, for the nonmetals gain electrons to have a full valence shell. So we need to figure out how many valence electrons each element has, and then to figure out the charge, just subtract that number by 8, and that's the charge. So let's go back to our example, magnesium sulfide. Like I said, magnesium is here, it's number 12, and it's in group 2. What that means is that magnesium has 2 valence electrons, and when it forms an ion, it's going to lose both of them. That means that magnesium has a charge that is positive, and it lost 2 electrons, so the charge is +2. Let's take a look at sulfide. Sulfide is right here. It's outlined in purple. It's number 16. And look at, it's in the 16th family. Well, if you look at the last number of 16, that's the number 6. That tells us that sulfur has 6 valence electrons. Well, in order to have a full valence shell, sulfur needs to gain some electrons, and the amount that it needs to gain is 8, according to the octet rule, minus the number of valence shells it already has, valence electrons it already has, and that equals 2. So that means that sulfur needs to gain 2 more electrons in order to have 8 in its valence shell. Well, when sulfur gains those 2 electrons, its charge changes and it becomes a -2 charge. So when we put magnesium with a +2 charge together with a sulfide with a -2 charge, let's add up the charges. A +2 plus a -2 equals 0. And isn't that what we needed in our final compound? The charges needed to equal to 0. So that means that we only need 1 magnesium and 1 sulfide, and so magnesium sulfide has the formula MgS. Let's do another example. Let's do an example with calcium nitride. So calcium is here in the same family as magnesium was. So calcium, being in column 2, has 2 valence electrons, and since it's a metal, it's going to lose those electrons. It becomes positive. And since it lost 2 electrons, it becomes calcium +2. Now, nitride is the ion for nitrogen. Nitrogen is in the 15th column. Look at the last number in 15. That means that nitrogen has 5 valence electrons, and if we subtract 5 from 8, we get the number 3, which means that nitride has a charge of -3. Now that we have the charges on our ions, we have to figure out how many of each we actually need. Well, you can simply use the crisscross method. If we take the 2 from calcium and bring it down here to the bottom of the N, and we take the 3 and we cross it over and we rewrite it at the bottom of calcium, we get calcium 3, nitride 2. Let's see if this compound has a neutral charge. 3 times a +2 plus 2 nitrides times a -3 charge each is going to equal 6 plus a -6, which of course equals 0. So our compound, calcium nitride, has the correct formula of Ca3N2. All right, we're going to try another one. Let's try potassium sulfate. Potassium is here in the periodic table. It's in group 1. So what's the charge of potassium? If you said +1, you are correct. And now for the tricky part. We have to figure out what the charge of sulfate is, but before we can even do that, we have to figure out what the formula is. Sulfate is not the same thing as sulfur. Since it ends with ATE, you need to look at the back of your periodic table at the polyatomic ions list. Sulfate has a formula of SO4, and this polyatomic ion has a charge of -2. So, in order to figure out what the formula is for potassium sulfate, I take the 2 from sulfate, and I'm going to rewrite it at the bottom of K. And I'm going to take the 1 from the +1 of K, and I'm going to rewrite it at the bottom of SO4. So my formula is K2SO4 with a 1. But remember that in chemistry, we don't write the 1s, so the 1 is going to go away. And our correct formula is K2SO4 for potassium sulfate. So those are all the different kinds of ionic compounds that you are going to come across in the quiz. But there's also some others that you are going to come across as well. For instance, what if we just have the word hydrogen? Actually, let me change that. What if we just had the word bromine? Well, we know that bromine has a formula of Br. That's for the element bromine. Is there a metal in bromine? No, because bromine is here on the right-hand side and there's no other atom in this compound. That means that it's covalent, and we just need to use prefixes in order to write out the formula. But look, bromine doesn't have any prefixes. Look at our next question, the blue one. Is it a part of high Broncliffe? And look, there it is, bromine. What that means is that bromine itself has a formula of Br2. That's not the same as bromide, which is Br with a -1 charge. These two are totally different. Bromide needs to be bonded to another atom. Oftentimes it can be a metal, but bromine can stand alone. So its formula is Br2. Let's try oxygen difluoride. So I know we have an O, and I know that we have an F. Are either oxygen or fluorine a metal? No. Both of them are on the right-hand side of the staircase, so they're both nonmetals. That means that we don't need to balance the charges. Instead, we need to use prefixes to write the formulas. Well, oxygen is just one oxygen, and the di before the fluoride means 2, and you can find that on your periodic table. So our formula for oxygen disulfide is simply OF2.